Hi everyone, welcome back to the channel. My name is Priyansh Agarwal, and in this video, let me tell you about my course called TLE Eliminators that I've been running from April 2021. So it's been 3 years since I've been running that course. We have taught more than 5,500 programmers through that course already. Now this entire course, is divided into 4 levels. So for somebody who is at a particular level in their competitive programming journey, they can choose to join a level and learn only those relevant topics. So first of all, you get live classes on all of these topics, right? Every single week, we have around 1 to 2 live theory classes, and we teach you all of these topics in a very structured manner. Secondly, we provide you with curated practice problems on all of these topics that we've taught you. For example, if I teach you dynamic programming for maybe 3 weeks, then in these 3 weeks, I am going to give you 2 to 3 problems every single day. Now, in case you're stuck on any practice problem from the course, you get dedicated video solution where we talk about the exact intuition involved. How do you think? Apart from this, if you're stuck on any practice problem from or outside the course, we provide you with instant doubt support. Now, what happens in doubt support is that we have a team of around 30 to 40 experienced competitive programming mentors. These mentors are already experts and candidate masters on Codeforces, and they help you solve these problems in which you're stuck. Like you could come up with a debugging problem, you could come up with a problem in which you require some hints, and overall, you get to learn a lot from the experience of these mentors. And apart from that, there are other pretty cool features. You can go and check out our website to explore them. One thing that I want to mention is that TLE Eliminators is a live course, right? So every 3 months we launch one single batch, and in one single batch we run all of these level 1, 2, 3, 4 parallelly. So you can go onto our website and check out when is the next course coming up, and if you're interested, you can sign up for that.
So this is the first problem, Farmer John's challenge. They say that we call an array sorted if this condition meets, that every element is either equal or less than the next element. And we have been given two integers n and k, and we have been challenged to find any array a1, a2 till an, satisfying the following requirement, that every element should be in the range from 1 to 10 raised to the power 9, and out of the n total cyclic shifts of A, exactly k of them should be sorted. So uh, we will see this thing again in OneNote also. And in case if we cannot find any subarray, then we have to output -1. Then they have given, like they have just told that what do they mean by cyclic shifts. And they have given some examples of array being sorted and cyclic shifts. Like if you see that there is an array 1, 2, 3, 3, then I like right now it is 1, 2, 3, 3. Then if you shift it once, 2 comes at the front and 1 goes at the back. So it becomes 2, 3, 3, 1. Then again this 2 goes at the back and the other elements come one step forward. So it becomes 3, 3, 1, 2. And then again we do the same and we get 3, 1, 2, 3. So that's it. We will be given n and k for every query and for every test case, and we will have to output either an array which satisfies the condition, or we will have to print -1. So I believe that everybody knows about sorting. Like everybody knows that what is a sorted array and what is not a sorted array. As an example, like they have already given some examples also. Like this is a sorted array because every element is less than or equal to the next element, whereas these other three arrays are not sorted because they are not greater, like every element is not less than or equal to the next element. They have been failing at this place, right? So this is done. Like we know what is sorting, and for the part of what is the cyclic shift, again I think that this is also something you people would have already got. If you have an array, maybe something like a1, a2, a3, a4, and so on, let's say till an, then a cyclic shift is nothing but instead of having this as the first element, have some other element as the first guy. Let's say that I say here a2 is the first element of the array, then have the array like as it is from a2 till the end, and after that place, after an, start with a1 till the element which you have chosen as the first guy. Since a1 had been chosen as the first guy, array will go till here. Let's say if you had chosen a3 as the first guy, then in that case um, the array would have been looking like this. This is also a cyclic shift. So I hope that cyclic shift is also clear, that how it looks. What we have to tell is the array, like we have to print an array, print an array of size n. This n will be given to us. And the challenge is, out of all the n cyclic shifts of this array, exactly k of them should be sorted. So if you have been given an array like a1, a2, a3, let's say like a1, a2, a3 can be any values. Let's say if this is the array, then the cyclic shifts will be, the arrays after cyclic shifts will be a1, a2, a3, a2, a3, a1, a3, a1, a2. And like these are the only three cyclic shifts. We will have to check how many of these are sorted. Basically, for how many of these this condition holds. And um, we want that exactly k of them should have these conditions to be held. Okay, so is the problem clear, guys? We will be given,
Yes.
and we will have to output such an array that it satisfies this. Now, the first thing which I think we should do, at least for the beginning problems, I used to do this thing when I was a beginner, and even now I do this thing, that if you get some intuition directly just after reading it, then it's really good. Just try to think about it. Otherwise, just go to the test cases. The problem setters intentionally create such test cases which will take care of the edge cases, so that mostly people are able to do this. Here as well, I just noticed this part, that for like 2 comma 2, basically where n and k are equal, um, basically I just saw the answer for it. It had both the elements as equal. So I got to the idea that, hey, if I take a1 equal to a2 equal to a3 and so on till ak, then for all the cyclic shifts, the array will have all the equal elements. So definitely I will get k sorted arrays. So if n and k are sorted, then just have all the elements equal. What I did is I just did set up all these elements as one. Yeah, we will do the proof also about it. But right now I'm telling about the intuition, that how would a beginner approach this problem? How would have a beginner done it? So this is the thing where I did approach, and I think that anybody could have approached in this way. Like if you're just looking at the test cases, even if you don't have a lot of experience, you could have got this idea. Secondly, since they had given a test case where the answer was -1, I was just trying to figure out that what is so special in this. How would um, basically just try to identify uh, what kind of test cases will have -1 as the answer. I was just trying to think about it, and then I realized one thing: key whatever array I print, let's say the array which I have printed is sorted for now, because k will be at least one. So um, from the array which I will print, I think that it's good to just print it in the sorted order directly. So if the array is sorted, it definitely means that a1 would be less than or equal to an. Right. Now, if I have any cyclic shift of this array apart from it, you can notice that a1 will come after an. Whatever array, from let's say it starts from ax, the array starts from ax and it ends at ax minus 1, where these can be any elements. Or even if you feel a bit overwhelmed with the variables, just think, yeah, the array can start from anywhere, from end at any place, just some cyclic shift. Let me take some examples, maybe 1 2 3 4 5, if it feels simpler. Let us say that this is the array, and I cyclic shift it once. Let's say I start it from here. Then it becomes 2 3 4 5 1. Now the idea is, this guy, this first guy, A1, would definitely be either less than or equal to AN, In the case if a1 is equal to an, this is the case which we just discussed a little earlier, because if the first and the last guy are equal and the array is sorted, then all the elements are equal. So basically this is the case where we will get k as the answer. In the other case, if a1 is less than an, then other than this, all the cyclic shifts will have one coming up after the an guy. Like a1 will come after an. And you know that this guy is actually smaller than an, so you will never have any other array sorted, right? So this clearly means that hey, you can get at most one array sorted in case if the first and the last guy are not equal. Basically the minimum and maximum people are not uh, equal. In case if all of the people are equal, then in that case you will have k sorted arrays. So your answer will be like whatever array you create, it will have either one sorted arrays or k. So sorry, not k, but n actually, for all the cyclic shifts. So if the value of k is 1, then just print anything like 1, 2, 3, and so on. Basically any sorted array. In case if k is equal to n, then just print 1, 1, 1, and so on. Are you going to do C2 and D? I will do till C2. And for all the other possible values of k from 2 till n minus 1, you will just print -1 because we just saw for like we cannot have any array which will have the value of k as anything else, right? So is the problem clear?
Yes, sir.
What about others? Guys, please write in chat whether it is clear or not, so that we can move on to the code. Okay, let's move on to the code. The code is pretty straightforward for this. Um, First of all, I took n and k as input. Then I did run up an if condition that hey, if n is equal to k, then print 1 1 1 1 everywhere. If n is sorry k is equal to 1, then in that case just print a sorted array. And here I'm writing I plus 1 because we are like the array should have at least 1 as the values of the elements. Basically, you cannot have any value equal to 0 there. So just run up a loop from 1 to n or anything. The array should be sorted, and the first guy should not be equal to the last guy. That's it. That's all we want here. You can print any array. And in the other case, if k is something between 2 to n minus 1, then print -1. So I hope that this is clear. We can move on to the next problem. This is the second problem of the contest, Bessie and Max. In the problem, it says that Farmer John has a permutation P1, P2 till Pn, where every integer from 0 to n minus 1 occurs exactly once. He gives Bessie an array A of length n and challenges her to construct P based on A. The array A is constructed so that AI is equal to MEX of P1 to Pi minus Pi. This Pi is actually talking about this array. Like for every I will actually show this thing on one note. Where MEX is where MEX of an array is the minimum non-negative integer that does not appear in the array. For example, MEX of 1230, MEX of 310 is 2. I think that MEX part should be clear at the very least. Keyword is MEX. Only this part might be looking a bit confusing, though it's also not really confusing. You know that maybe I will show this. And then the last line says that help Bessie construct any valid permutation P that satisfies A. And the input is being given in such a way that at least one valid P exists. And in case if there are multiple permutations, it is enough to print one of them. Okay, so guys, just please confirm in chat that I think that you people have understood what is MEX. If you have been given an array, maybe something like 0, 1, 3, 4, MEX is nothing but the smallest non-negative integer which is not coming up in the array. Here you see that 2 is the smallest non-negative integer which is not coming up in the array. And we have been given some permutation Let me write a permutation here, a random permutation, or maybe let me just write up this answer. 0, 1, 4, 2, 3. 0, 1, 4, 2, 3. So we have, like, for a permutation, if we have a permutation, then the array A is created in such a way that AI is equal to MEX of the permutation from P0. Right now I'm writing in zero based indexing till Pi minus Pi. So here for A0, we have the MEX of the prefix till this point as 1. MEX is 1 and the array element is 0. So A0 will be equal to 1. Then for this prefix, you see that MEX is equal to 2. We have, like, the smallest non-negative integer which is missing here is 2. And the value here is 1. So 2 minus 1 will also be equal to 1. Now, can somebody tell me what will come up here? What is the MEX of the first three elements? MEX is still 2 because we have 0 and 1, but we don't have 2 here. And we will subtract Pi from it. So 2 minus 4 will actually turn out to be minus 2. Then for this prefix, for the first three elements, here the MEX will now be equal to 3 because we have 0, 1 and 2. So MEX will be equal to 3 and we are having Pi equal to 2 here. So again, we will get AI equal to 1. And then for this prefix as well, we have MEX equal to 5 and the element is coming up to be 3. So we will print 2. Yeah, MEX is 5 and we are having 3 here. So we will print 2. I hope that it is clear on, like, how we got the array A. I hope this part is clear. What we will have is, we will have this array A and we will have to print any permutation P such that it also gives this array A. Like, if you construct array A from that P, you should get the same permutation. Sorry, the same array A. Is the problem clear? Guys, please write in chat. Does anybody have any problem with the problem statement, or is it clear? Can we move on to the approach? Or at the very least, can we move on to the observations here? Okay, looks like it's clear to everybody. Yeah, so at the very least, I think that you might have seen one thing. If at any place, um, if at any place you got, when you inserted 2, if the MEX of the array changes, like let's say at Pi, for the ith index you had Pi, and inserting this thing, like, because of this thing, the MEX you had till here and now the MEX you have got here, if this changes, it means that Pi must be less than MEX now, because or maybe I can give you another intuition. At the very, or maybe even before that, one very obvious thing which you might be able to see directly is, when you got all the elements till 0 in the first like in the prefix of length 1, when you got all the elements till 0, AI turned out to be 1. Then when you got all the elements till 1, then the MEX turned out, sorry, AI turned out to be 1 once again. When you got all elements till 2 here, like 0, 1 and 2, again the array A turned out to be 1. It is coming up because this 2 which you inserted, because of this the MEX changed. Like, the MEX changed, or let's see, how can I teach, like, how can I tell in a very intuitive manner? Maybe let's say I have some elements 0, 1, 2, and I insert 4 here. Then guys, what do you think? If from in the array which I had earlier, 0, 1, 2, I insert 4, will the MEX change in the array? If I insert 3, will the MEX change? No. Easy peasy thing. MEX will not change here. At the very least, I can easily tell here if whatever element I put up, Pi is greater than the current MEX, then in that case, MEX will not change. And since you know that Pi is greater, MEX minus Pi will turn out to be negative. But in the other case, if let's say now I insert 3 here in the array, then will the MEX change? Okay, like I've not started any approach. Right now, I'm just willing to pick up the observations which a beginner can pick up. The very first thing which directly came up in my mind, and I think that this one is something a beginner can see. Here, when my MEX changed, when I got all the elements till 0 here, my MEX became 1 and I got AI equal to 1. Then for the first two elements, I had both the first two elements 0 and 1 when I inserted 1, and my MEX again turned out, sorry, AI again turned out to be 1. Then at this place, when I got an element which is greater than MEX, then my AI turned out to be negative, which is obvious. If my PI is greater than MEX, then like MEX will remain the same. PI is smaller, sorry, PI is greater. So MEX minus PI will turn out to be negative. Secondly, if I have some element which is actually equal to the MEX of the array, if I insert, like, look at this array. When I had 0, 1, 2, and 4 in the array till this point, and I insert 3 into the array, which is equal to the MEX so far, then in that case, can I say that MEX will increase? Basically, MEX will increase only if PI is equal to MEX. Like, does it look intuitive now? Does it look intuitive? Ki if my Pi is greater than, okay, let's start it once again. Somebody said he has doubt. Is it clear till this point that if you have been given the permutation, you can create the array? And what we have been given is the array, and what we have to create is any permutation which creates this array, right? Now, there is one observation which I want to make up here. When I insert, or maybe just leave it. When I insert an element which is equal to the MEX of the array so far, when my Pi was equal to the MEX, in that case, MEX will increase, right? This is the only case where MEX can increase in an array. If you have an array, let's say 0, 1, 2, 4, then the only way you can create the MEX of this array by inserting one element is by inserting the MEX. If instead of 3 you put up anything instead of this 3, then the MEX of the array will remain the same, right? I think this part is also not hard to understand. The MEX of the array will only change when you insert MEX, right? What if element lesser than what we are inserting is absent? See, when I'm saying here 3 is the MEX here, it means that all the elements smaller than 3 are present, right? When I'm saying here 3 is the MEX of the array till now, then it means all the elements smaller than 3 are present. So when I insert 3, then I can say that all the elements less than equal to 3 are definitely present, and the MEX of the array might increase even more depending upon which elements are already present, right? Here you see that when I inserted 3, since I already had 4 here, the MEX now actually became equal to 5, right? MEX actually became equal to 5. So I don't really know ki how much will it increase unless I look at the elements of the array. But I know that it will definitely increase at the very least. So in a nutshell, what I'm trying to point out is, if the new element which I would have inserted here, if this element would have been equal to the MEX of the element so far, in that case, the MEX will increase, since this new MEX, this new MEX would be greater than the previous MEX, or you can say that it would be greater than PI. Therefore, this thing, MEX minus PI, would be greater than 0. Anything it can be anything. Like in this case, it is 1, 1 here, whereas in this case, it is turning out to be 2. Does it make sense? Guys, does this thing make sense? If like the thing which we can conclude from here now, like we can make a conclusion here. If I know ki whenever I insert an MEX, my AI will be greater than 0. So can I conclude ki if the guy is actually greater than 0, then I must have inserted the MEX at this place. If this is greater than 0, then it means that this like at the place of the permutation, we must have an MEX. By prefix and suffix, I'm not really sure about it. But tell me about the approach I've discussed so far. Does thing make sense now? Let me give a very small recap also, because we did discuss multiple things, so it might have been looking a bit scrambled. Let's say in the array, I'm having something like 1, 1, minus 2, 1, and 2. Now, tell me for what elements are possible. Like for what elements can I have a 1 here? In the permutation, right now, I don't know what elements I might have. But I know that as like, since I have not included any elements in the array till this point, like since my permutation is empty before this I, my MEX would have been 0 before it. Now, guys, tell me, what do you think? What can be the first element here? If the first element is anything other than 0, then MEX of the array will turn out to be 0. And since I'm inserting something, since I'm inserting a 1 here, I will get some negative value for array. But I know that we have some positive value, right? So can I conclude that I must put up the MEX at this place? First of all, tell me that is this part clear key? If you put up anything other than the MEX, then you will have a negative value. If you put up anything greater than the MEX here, or do I need to repeat from the beginning? I'm just a bit confused that in case if the starting part is not clear, then it might cause some trouble. Let me just repeat it anyways. Maybe people on YouTube might feel कि fast repeat किया होता.
सर MEX वाला तो समझ में आ गया, पर MEX चेंज किस तरीके से हो रहा है, उसे प्लेस किस तरीके से करें, उसमें कंफ्यूजन बहुत हो रहा है. सॉल्व करते टाइम भी मेरे को यही दिक्कत आ रही थी.
Okay, let me start from the complete. Let me start from the beginning once again, and we will see it again. See, let's say the permutation is something like 0, 1, 4, 2, 3, and array A. What will be the first value of the array? Try to think about it. When you insert the 0, like for A0, you will have MEX of 0 minus 0. Since MEX of 0 is actually 1, so 1 minus 0 will come out to be 1, right? Right? When you like, since P0 is 0, So MEX till this point of all the elements till this point minus this guy, you got 1. Then talk about the like index 1. You will have MEX of 0 comma 1 minus 1, like the current element. Again you will got again you got a 1. Then at the next place, when you inserted 4, 0 1 4, the MEX did not change now. Like notice this part. Earlier, whenever you were inserting some element and it was contributing, like it was equal to MEX, so it was actually increasing the MEX. See this part, even leave the part of being equal to MEX. Just see, when you inserted 0, the MEX became equal to 1. So you got some positive value in A0. When you inserted 1, the MEX became greater, and thus like the MEX became greater than 1, and thus you got some positive value. When you inserted 4, MEX is still equal to 2, right? MEX is still equal to 2, and you are subtracting from 4 from it, so you got a minus 2. So can you guys conclude at the very least one thing, ki if the new element which I'm putting up, if the new element which I'm putting up, which is equal to Pi, is equal to MEX, in that case AI must be positive. Like we don't know how positive, how, like what will be that value. That value might be 1, that value might be something else. We will see this thing in a little while later. But at the very least, can I conclude that the AI will be positive? Guys, yes or no? Does this thing make sense? Ki when I inserted some element which was changing the MEX of the array, and this is not, like this part is not hard to understand, ki uh, if you have some elements, let's say 0 1 2 4, and you insert some new element x and the MEX of the array changes, then this element must have been equal to the MEX. Like this element must have been equal to 3, because if you take up, just try to do the try run, if you take up any value other than 3, then you will see that MEX will remain the same. So the only way to change the MEX is by inserting MEX itself, the value which is equal to MEX. Guys, yes, no, tell me something. Does this part make sense? Are you able to see it now? That when the new element is equal to MEX, in that case AI must be positive, because MEX, like if Pi is equal to MEX, then MEX will increase, the new MEX value will increase, so it will become greater than Pi. Therefore AI will definitely be positive. And you know that Pi can never be can never be smaller than MEX, since all the values, like we are talking about a permutation, so all the values are unique. if you have if you have MEX equal to 10, it means that you're already having 0 1 2 till 9 in the array. So the Pi cannot be any one of these. It will definitely be greater than equal to MEX, है ना? Which means in case, like you know that Pi less than MEX is not possible, Pi equal to MEX will have AI being some positive value. But what if Pi is something greater than MEX, than the MEX we already had? You can see it here. Yeah, if you put up something greater than MEX, like this thing will not change, it will remain as it was earlier. So you will get some negative value. So here you will get some AI being negative. Can you guys try to identify what value will it have? Let's say you know about the value of MEX, because since we will be creating the permutation, let's say you know about the first two values of the permutation. Let us say you know that array A is having 1 1 minus 2, and it might have something else also, and the permutation for the first guy, since it was equal to 1, you know that it is positive, it must be equal to MEX. So you got it. Yeah, since it is gonna be equal to the smallest positive element missing in the permutation so far. It is 0. Now AI here is also 1. It is still positive. It means that the smallest smallest non-negative value which is absent here. What is the MEX in this permutation so far? It is equal to 1. So yeah, you know that PI here would also, like, PI here will be equal to 1. Now for this guy, here that whatever MEX you had so far here minus some PI which you should have will be equal to it will be equal to -2. Like AI was, if you remember, AI was equal to nothing but MEX minus PI. You know the MEX, you know that MEX is 2. You know about AI, which is -2 here. So can I say that we can figure out what is the value of PI in this way? So the basic formula will be MEX minus AI will be the value of PI if AI is negative. So we can put up a 4 here. Similarly, like for the remaining array, here AI was 1 at the 4th place. So what will be the, like you see that AI is positive, so what will be the PI we put up here? It will be equal to MEX, that is 2. Then the last element was, I think, equal to 2 here. Yeah. Again, it is positive. You know that it will come up positive only when PI is equal to something equal to MEX. So you have to put up 3 here because 3 is the smallest non-negative element absent here. So we have now completely discussed about the approach. So now guys, tell me whether the complete approach is clear or not. With this formula, work for both positive and negative number. See, for positive number, like if AI is greater than or 0, greater than equal to 0, actually, if you see, it will never be equal to 0 either. It would always be either greater than 0 or like either it would be greater than 0 or less than 0, because it is not possible ki you have some elements in the MEX whose like you have some elements in the array whose MEX is coming out to be equal to this guy because this guy is present, right? So if AI is greater than 0, in that case, we will just simply print the MEX. Basically, we will say here PI is equal to MEX of the array so far. That is the MEX of P0 till Pi minus 1. And if AI is less than 0, then we will simply say here that Pi is equal to MEX of whatever things we have got so far, like the same thing from P0 till Pi minus 1 minus AI. This will be the two things we will have. Now, one confusion you might have is how to find out the MEX. Let me just inform you. Yeah, constraints are pretty huge. So, how will you make sure that you find out the MEX in some efficient manner? So, for this, what you can do is just use a set. Not really sure if we like unordered set is not something we prefer. You can just simply use a set of integers, or if you want, you can use an unordered set. And in this set of integers, you can just keep track of all the elements that you haven't got so far. So basically, all the missing elements, all the elements which are missing in the array from 1 to n, you can just, sorry, from 0 to n, you can just store all of them, and in this way, you will be able to check out the MEX by looking at the smallest value in the set. Or if you want, you could have done the other thing. You could have just pushed up all the values which you have got so far in the set and just run up a while loop again and again for checking out the value of MEX. Both things will have the same time complexities, but I think the one which I'm speaking here is better. So shall we move on to the code part? Like, I think that we have discussed the complete approach properly. I used DP to solve it, but approach was helpful. Okay, I would say that try to look up at this approach instead of DP. Let me look at the chat once. There were some messages who were saying that please move to code, but at that time I could not move to code since I had not discussed the complete approach. I solved the question in 40 minutes, sir. How did you manage to get it in 6 minutes? Like the approach which I discussed here, I just did the exact same thing. But obviously I did not spend up a lot of time at proving everything or explaining everything slowly. I was just a little quick there. Will this formula work for both positive and negative? I've discussed that thing. Okay, so let's move on to the code. The code for this approach, the code for this problem is also pretty straightforward. What I did here is, first of all, took up all the inputs, then created a set and pushed up all the values which are not present in the permutation so far. That is all the values from 0 to n. If you want, you can put up even more values, but you know that MEX will never be greater than n, since you cannot have more than n elements in the array. So MEX will never be greater than n. So I think that this is a good spot. Like this is a good thing which you can notice. And then created an answer array, and for each I from 0 to n, if in case ai is greater than or equal to 0, we know that answer of I, basically the array which we have to print, must have the MEX here. So answer I must be equal to the smallest possible value which is not present in the set, which we can get in this way, dereferencing st.begin. If you know about sets, you would have got it easily. In case if you don't know about sets, then please try to study about them first. And then we can just erase that value from the set because we have got it in our permutation. And in the other case, if ai is smaller than 0, then you know that it will be equal to MEX minus ai, and just say your answer I will be equal to MEX minus ai here, and erase that value from the set. So I think that this should also be clear. Let me read the chart to get the idea of what you people think. MEX is equal to PI plus AI. After we put PI is equal to MEX, but AI is equal to 0. Yeah, actually, actually that thing is correct. We didn't even need the set. When like as we have been doing here, that st.begin minus ai to get this x. Similarly, here when ai is greater than 0, MEX will also be equal to something like the previous MEX plus ai, something like that. This is a good observation. We can reduce use of set by using this. Yeah, we can ignore the set using this. Yeah, the MEX of the last element is always n. Can you explain that set part which is ai equal greater than 0 in my code, or are you asking for code or logic? In code. Okay, so see, what we discussed so far is, in case if ai is greater than 0, here just for safety purpose I wrote equal to also, but it will never be equal to 0. We just saw here, hey, in case if ai is greater than 0, then pi is equal to MEX of the array so far. Now how will you get to the MEX? For that we said key, all the values which are not present in the permutation so far, just push them up in the set, and whenever you get some value in the permutation added, just remove it from the set. So that's what I'm doing here. And st.begin, dereferencing it, can give me the smallest value in the set. And if you see, set is containing only those values which are not present in the permutation. So I'm getting the value of MEX in this way. And st.erase, st.begin will just erase the smallest value from the set. You could have actually said st dot erase ai, sorry, answer I. You could have said it like that as also. In your set, you have all possible mx. No. In my set, I'm just pushing up all the values which are not present in the permutation so far. This is actually a pretty standard way of keeping track of the MEX while traversing an array or inserting values inside some array. Just to keep track of all the values which are not present in the set, and the smallest one will be the MEX. Okay, so guys, shall we move on to the next problem? Cool. This is the third problem, Bessie's birthday cake. The problem says that Bessie has received um, a birthday cake from her friend Elsie, and it came in the form of a regular polygon of n sides. The vertices of the cake are numbered from 1 to n clockwise. You and Blessy are going to choose some of those vertices to cut non-intersecting diagonals. I don't know why are they having such stories. Let me just show you what it is. The problem is you will be given some integer n. You and you will have a regular polygon of that many sides. I hope that you guys know about a regular polygon. A regular polygon is nothing but, um, let's say if I say a regular polygon of n sides, then it means that it will be a shape having n sides. Here it is having 8 sides, and all of these sides will be equal to each other. And similarly, all the angles here will be equal to each other. If you want, you can search about regular polygons online. Baki, I think figure is good enough to just get some idea of what it is. Um, Along with this n, you will be told about some points, like there will be some points chosen. In the problem, it says that we will choose some vertices to cut down non-intersecting edges. In other words, the endpoints of the diagonals, which must be the part of the chosen vertices. So it is like if you have a regular polygon of, let's say, 8 size, this is also known as an octagon. Here you will be uh, given some edges as well, or sorry, not edges, but some vertices. And what you can do is you can put up some diagonals and use these, like where you will have to use these points as the endpoints. They have said this thing that, in other words, the endpoints of the diagonals must be the part of the chosen vertices. So, like if these are the 4 chosen vertices, then you can create only those diagonals which have these as the ending points. Like this kind of a diagonal is valid, but this kind of a diagonal is not valid since it is having this as a chosen, like as an endpoint, which is not chosen. And there is one more thing. You have to choose diagonals which are not intersecting. Like you see there, if you create 2 diagonals like these, then they will intersect here. This is not allowed. You have to choose diagonals which are not intersecting with each other, or basically non-intersecting diagonals. And um in the follow-up of this problem, we will have something like y as well. Y will be the um, like n is the number of sides in this regular polygon, x is the number of chosen vertices, and y is the number of vertices which you can choose by your choice. Like x is the number of chosen vertices given to us. These vertices are given to us, whereas y is the count of the vertices which you can choose by your choice. In this problem, it will be equal to 0. In C1 problem, it is equal to 0. In C2, it will be something given to us. So we will see that thing in C2. Till now, is the problem clear? Guys, is the problem clear? Okay, great. So let's try to make the problem simpler. Let's say n is equal to 3. Actually, n can never be 3, so we can ignore this. Yeah, n will always be equal to at least 4, so let's ignore it. Like we are right now just trying to look up for the simplest problem we can think about. Let us say n is equal to 4. Because directly thinking about a harder problem might be hard, but thinking about some easier version of that problem can be simple. You can get some idea about the problem here. N is equal to 4, and just for simplicity, let us say x is equal to 0. And y will always be 0 for this even problem. So guys, what should be the answer? Oh yeah, one more thing, like I just forgot to tell. Uh, we have to tell what is the maximum number of triangles we can have after drawing those diagonals. The maximum number of triangles possible, like in the shape where you have 8 vertices in total, 4 chosen vertices. Here, if you draw these like the diagonals in this way, then you will have this is the one triangle and this is the other triangle. Does x array affect the answer? Yes, x array can affect the answer. For now, we have taken x is equal to 0, so there are no chosen points. Do you see any triangles here? Do you see any triangles here? No, the answer is 0. Here we have 0 triangles. Since there are no chosen vertices, we cannot draw any diagonals. So right now there are no triangles and we cannot even create any diagonals. Let us say this guy, this guy, this guy, and this guy. Like we got to know if x is equal to 0, the answer is always 0. We did not really learn much from it, but just for simplicity, we took that case. Now let us take a harder case. If x is equal to n, what is the best thing which we can do? In the problem, actually they have it given to us. We can draw diagonal in this way. They have actually shown it. They've actually shown us. We will get two diagonals, 1, 2. Sorry, two triangles, 1 and 2. So we got to see here what we can do for n equal to 4. Either you draw a diagonal like this one, or you could have drawn the diagonal in the other way. It does not really matter. What matters is that you got two diagonals. Then what I did is I tried to look up for something a little harder, like this test case, where we have n equal to 5, and let us say that all the diagonals are all the vertices are chosen. What best thing can we do? I was just able to get this till this point only. Like I realized that I can get only three diagonals. Sorry, three triangles. Then I looked up for 6. By the way, till this point, I had started to get the idea. Here in octagon, for 8 sides and 8 vertices, we were having 6 as the answer. For a square with 4 sides, we got 2 as the answer. For a pentagon with 3 sides, sorry, with 5 sides, we got 3 as the answer. So probably the answer might be something like n minus 2, where n is the number of sides of the polygon. But still, it's a good thing that you just check out. And like the best thing I could think about was this, to get 4 triangles. And by this point, especially because of this guy, I had been able to notice one part. Let me just put up my laptop on charger once. Yeah. So I had got one idea at the very least. Um, in this kind of a case, if you draw a diagonal like this, you will get rid of one vertex. You got rid of one vertex, and your number of triangles which you could create increased by one. Now, this remaining shape you have is actually similar to n equal to 7 and x equal to 7. Can I say this thing? That once I draw a diagonal like this one, now this guy cannot interact with anyone now. है ना? This guy cannot interact with anybody now. So this thing, like the remaining shape, is actually similar to n equal to 7 and x equal to 7. And then I realized here, if I just create one more diagonal like this, I will get, like here I got one diagonal, sorry, one triangle, and now I got the second triangle. Now it is actually equivalent to n equal to 6 and x equal to 6. And this thing keeps going on until you are left up with a triangle only, with a single triangle. So I got actually got a visualization here of why my answer is always coming up to be n minus 2. And I got the idea, yeah, since taking down, like removing a vertex was not really causing me much trouble, because like when I got rid of this one vertex, the remaining shape was actually equivalent to this, and my answer was also equivalent to this, right? When this vertex, even though it was a chosen vertex, could not interact with anyone else now, in that case, my answer, my remaining answer, the number of triangles in the remaining part, was actually coming up to be equivalent to this. So I got one idea. Here, let us say, let me draw it. Yeah, let us say that this is the um, regular polygon we have, and these are the chosen vertices, these four. Then I just had this intuition that if I connect this guy with this guy, if I connect this guy with this guy, now it is actually a square, right? This is actually a square. So, like right now, any number of vertices it will have. If since there were x chosen vertices, um, like right now we can see that there are 4 chosen vertices. But for a bigger shape, if it had x chosen vertices, then at the very least you will get x minus 2 triangles being created in the normal way as we had been getting for all the shapes. Are you guys with me till now? Did you guys understand this idea? First of all, tell me about this idea, that for any shape where all the people are considered as the chosen vertices, we can get n minus 2, right? And this idea, removing one vertex which can now no longer interact with anyone else, was actually um, like for the remaining shape, I was actually getting the same answer as I was getting for the complete shape. So similar to this, I can just ignore these vertices and keep only those vertices which are the chosen ones and can interact with others for diagonals. So if there are x vertices in the, sorry, yeah, if there are x vertices in the given shape, then at the very least I will get all these answers. But there is one more thing. Come back to the problem and tell me, does it matter whether this guy was a chosen vertex or not? Even if he was not a chosen vertex, I'm not having any diagonal through him. So my answer will still remain the same. Can I say this thing? Even if it was not a chosen vertex? In fact, this thing goes on for more people. Um, like the pentagon which we discussed. We have been seeing this thing at a lot of places, that we got In this way, we got 3 triangles. Even if this guy was not a chosen vertex, it is still fine because there is no diagonal coming up to this node. Similarly, this node is also not having any diagonal, right? So I think that we have got some intuitions so far, right? Can I say whatever shape I have, like for whatever shape I have, if this was the chosen vertex, 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 maybe this one as well. In that case, I can actually say one triangle, two triangle, three triangle. I got 3 triangles and then I got a pentagon. So this pentagon will give me 3 triangles and I got 3 other triangles. In this way, I'm getting 6 triangles here. Does this thing make sense? Ki, like for all the points which you have, just connect them. So you, if you have x chosen points, you will definitely get x minus 2 triangles from them. And for all the other points which are not chosen, just check if both of their neighbors, like both of its neighbors, are chosen or not. Because if both of its neighbors are chosen, then connecting them, which I will definitely connect for creating this pentagon shape, will actually give me one extra triangle, and it will happen every time. So my answer is simply x minus 2 plus count, where this count is the number of vertices whose neighbors are chosen. I think that it should be making some sense. Which part do you want me to repeat? Like this part, I guess, or something before also? Like something else also? Yes, that count part. Okay. So by this count, I'm only talking about the number of vertices like this one, and this one. The number of such vertices whose adjacent vertices or neighbors, the neighbor vertices for which guy, for the people whose neighbor vertices are chosen. Because if they are chosen, they will have a diagonal along them, which will create a triangle here. So the CNT will only have these values. Here CNT will give you 3. And since x is 5, like x is 5, you will subtract 2 from it to get the number of triangles in this region, plus the number of such vertices whose neighbors are both chosen. So you will get 3 such vertices, and the answer now turns out to be 6. Shall we move on to the code part? Okay, let's move on to the code part then. The code for this problem is also simple. First of all, I took nx and y as input. Then for each and every, like just took up all the inputs, and I prefer to keep them in 0 based indexing. It's up to you. If you want, you can keep them in 1 based indexing also. And then I created a set of all, like a set in which I just put up all the vertices I had got so far here. Um, like I think it's not really necessary to create a set, but it's a good thing. I just like set because it made the code comparatively a bit shorter. So I created a set in which I just put up all the chosen vertices. My answer is initially x minus 2 because I know that I will at the very least get this much answer. And then for each and every vertex, I'm just checking if, like instead of checking for this vertex, that the vertex ahead and before, whether both of these are chosen or not, since the numberings will be in this way 1, 2, 3, 4, 5, 6, which 1, 2, 3. 5, 6, 7, 8. I would have numbered them as 0, 1, 2, 3. First of all, it was initially 6, but out to make it 5, 6, 7. I would have, and let me write it once again. So it will have 0, 1, 2, 3, 4, 5, 6, 7 as the vertices. Now what I'm doing is for every vertex, I'm checking that, hey, if like I'm iterating over the array of the chosen vertices. So I already know that if I'm coming up at this, if this is my AI, if this is my AI, then this is actually the chosen vertex because I'm only traversing the chosen vertices array. And I'm thinking that, hey, if this guy is not a chosen vertex, like this is not a chosen vertex and this is a chosen vertex, then I would have connected these two. So this thing would have not been counted in my shape, like the shape which I was creating by connecting all the chosen vertices, but there would have been a triangle which would have been generated here. So I'm adding one for that. I'm adding one in that case. So I'm just checking for the next node that it should not be in the set, and the next of the next node should be in the set. If the both of these conditions fall true, then in that case, I'm incrementing the answer, and at the end, I'm printing the answer. So does it make sense? Guys, does it make sense? Why mod n? The point behind doing mod n is AI, like here AI is 7. The next vertex is having a value 0. Like 7 plus 1 is 8. But like you are pointing all the values from 0 to 7 now. So 7 plus 1 mod 8 will actually give it a 0. I think that this is something you might understand better when you try it yourself. Similarly here, for the vertex which is coming up 2 steps later, 7 plus 2 mod 8 to get this value. We are not checking for both neighbors, whether both neighbors are selected or not. If you want, you can do that as well. Like if you want, you can check for every node whether the node with coming next and the node which came earlier, whether both of these are selected or not. But instead of that, what I did is for each and every selected node, I just checked key if the next node is not selected and the next of next node is selected, then for this node, just increment the counter for this node. Um, okay, so great. Shall we move on to the next problem? Yeah. You can ask, Akhilesh. If the points are 1, 2, 3, 4. Okay. So maybe just I can just try it here. That if you are asking that, hey, if 1, 2, 3, and 4, if these are the only points, first of all, you would get a shape of size 4, so you would definitely get 2 triangles here. Secondly, for each and every of these points, we are checking if the next node is not selected and the next of next node is selected or not. And you will see that for none of these points, you will get this condition true. So you will actually get no answer incremented, which is uh, as we want, right? So answer is coming up to P2, which is what we
Right.
want. Yeah. Speak. Okay, you got it. Great. So shall we move on? Okay, cool. I won't erase it because in the follow-up problem, we will just have something being added in this problem only. In the C1 problem, if you remember, y was equal to 0. In the C2 problem, we can have y being in the range from 0 to n minus x, since x points are already chosen. Um, okay, let me tell you what is y. Somebody is asking, will you solve D&D? No. C2 is the last problem we will discuss today. Okay, so in the second part of the problem, it is saying that you will be given some chosen points as you were being given in C1. But along with it, like as we had n equal to 8 here, x equal to 4, and then we were being given an array of 4 points, these 4. Along with it, we were earlier being given y equal to 0. Now this y can be anything from 0 to n minus x, and let's say here and y is equal to 2. What we can do is, from the remaining points which are not chosen yet, we can choose 2 points of our choice, and what we want is the new, like let's say I choose this point and this point to be a part of uh, to be considered as the chosen points. So these 4 are being chosen and being given to us through the input, and these 2 are being chosen by us arbitrarily. Then the number of triangles, then the total number of triangles we get should be maximized, and we will have to print that total number of triangles. First of all, tell me, let's say if I have decided which points should I choose, can you guys figure out what will be the total number of triangles? The answer is yes, we can easily figure it out. How? We just did the exact same problem earlier. Like in the last problem, it was the exact same. That you will have a shape being formed by these elements first, and you can just find out the total number of triangles. Here it is coming up to be 1, 2, 3, 4, 5, 6. Right. So basically, we know that in case if we can figure out which points to pick up, then finding the total number of triangles is not a big deal. We have already done a problem like that. So this is something we can easily do. But which is exactly the previous question. The previous question I'm talking about is C1. Like in C1, we had been given some points and we had to find out the total number of triangles. Now in C2, along with the given number of like some given chosen points, we can choose some points by our own choice as well. And what we want to do is we want to maximize this total number of triangles we can form. So for this, like I think that most of the work which will be done by is by you. I'm not gonna be explaining each and every test case. Um, Otherwise, it won't really help you much. But I will actually mark down all the possible cases I could see, possible cases which I saw. Let us say between this and this, there is one point which has not been chosen. Like in this in this part of the polygon, whatever is being chosen, we don't really want to complicate things. So let us say that anything could be chosen here. But this point is not chosen and these 2 are chosen. So should I use one of my operations which I have y number of operations for choosing, like I can choose y nodes. So should I choose this vertex or not? Will it increase my answer by anything? Exactly. Even if I chose this, it won't really increase anything because I have already considered this triangle in my answer, even if I don't have it. let's try to change it a bit. What if like anything can happen in the remaining portion, but these two are not chosen. These two vertices are not chosen, and these two vertices are chosen. Should I choose any one of these points? Will it increase the number of triangles I will have? Remember that since these 2 points are chosen already, we will have this diagonal present. You can choose any, like let's say that you are having so many y operations. It's up to you if you want to choose both of them, none of them, or choose only one of them. But tell me, okay, let's talk about this. If we choose both of these points, what will happen? If you choose both of these, you will create a diagonal like this one, and applying the operation on this will just go into waste, right? It will just get wasted. So it makes sense. Here I apply the operation on only either this or this, and when I apply the operation on this, I will get 2 triangles added. So in case of let's let me just write things somewhere so that we will at last look at it for developing observations. When there was one node which was not chosen between some chosen nodes, um, it was taking 0 operations from my side. I was not requiring any operation and was getting a +1. If you see, like we did consider this triangle um, during the previous implementation as well. Like we are not really applying any operation and we are getting one triangle here, right? When there are 2 points which are not chosen yet, we apply one operation here and we get 2 triangles added. Let us consider the case if there are 3. I just deleted it by mistake. Let me just erase it. Let us consider the case if there are 3 not chosen points. Let me draw it a little better. Let us say these 2 points are chosen. These are like, I don't really care how the remaining part of my polygon is looking like. But here I see that there are 3 joints, 3 um, vertices in a row which are not joined, which are not chosen by anyone yet. So how many nodes should I choose? I think it is quite intuitive that if you choose the middle one, like just try to look at as a pentagon here. Just try to see it as a pentagon, because you know that there will be a diagonal here. So even if you choose these nodes, this triangle will still remain there. In a pentagon, if you remember, in the pentagon, okay, we did not discuss that part earlier, but see, when I insert diagonals, some nodes go in a way that even if, like, it doesn't matter even if they were chosen or not. Similar to that, I can just leave this node and this node and create diagonals in this way. I will get 3 new triangles by just having a cost of 1. I will give the complete crux just in a while. We are close to getting some intuition here. So did you guys get the idea here? If I choose this node, let me just mark it. If I choose this node and have these 2 diagonals, I will get 3 triangles, right? So let me just write it. Let me just keep it drawn as well. We got 3 triangles. So basically, for a size of 3, it took me a cost of 1 only, and I got plus 3 triangles. We are already seeing some pattern here. And like what I did is I just tried out for 4 nodes as well. That what if there are 4 unchosen nodes connected to some chosen nodes? Then I realized, yeah, choosing something like, let me show you how to draw a pattern here. Something like this, where I choose, sorry, I don't have to choose this many. I was just choosing two nodes. Like this is the first node I chose, this is the second node I chose, and just draw a diagonal in between. So 1, 2, 3, 4. Yeah, for 4 nodes, like for 4 unchosen nodes in front of you, I just did it. That we can see, if there were 4 unchosen nodes here, you can choose 2 of them to get +4. So for 4 nodes, it is giving us a cost of 2, and we are getting +4. Similarly for 5. Similarly for 5, you can try this thing out. I chose this one, and like let me see which. Sorry, I will choose this one and this one, and connect the nodes. Something like this. 1, 2, 3, 4, 5. I got 5 extra triangles. Like this is a very basic part. That's why I'm not really explaining for 4 and 5. I did explain it for 1, 2, 3 slowly. So for 5 unchosen nodes as well, I'm having a cost of 2 and I'm getting +5 in my answer. So here we can actually see a pattern that if there are some nodes not chosen in the way, if there are some unchosen nodes in a group, with let's say x, there are x unchosen nodes in a line, you will have a cost of x by 2 and you will get x incremented as your answer. Does this thing make sense? Like, can you see this pattern coming up here? If you want, you can check out for 6, 7, like bigger numbers also. I think that I did confirm this thing with 6 also, that it was taking me 3 operations to get +6. And there was one more thing in my mind, that what if I'm not having 3 operations? Let's say, or let's talk about this one actually. 6 is too much. Let us say I'm having 5 unchosen nodes, and I'm having only one operation. Let us say I'm having only one operation. Then what is the best thing I can do? So let me think what was the best thing I did. I think I did something like choose this and this. Yeah, just choose one vertex if you have only one operation. Leave one vertex, choose the other one, and then I got 2 triangles by using one operation. So if the y is less than equal to, or actually is less than x, then I can use those y operations to get 2 into y as the reward. Similar to this, you can say that even for the even numbers, you are just getting the double amount. So like you can just ignore it for now then. Like because we just saw that, hey, if y is less than actually x by 2, if y is less than x by 2, which is the number of, like the number of operations you require, in that case for every operation you have, you can generate 2 triangles. And in case if y is actually greater than equal to x by 2, then for the case when x is even, for the case when x is even, you are still getting 2 into like for x by 2 operations, you are still getting x by 2 into 2 as the number of triangles, the number of new triangles. But for the case of even, but for the case of odd, when x is odd, then for x by 2 operations, you are getting 2 into x, 2 into x by 2 plus one number of triangles, right? This case, or basically x. So the idea which I had in mind is, it makes more sense to first of all iterate over the triangles with the odd x, where x is odd. By the way, we have already covered up in the previous problem, the approach which we had developed in the previous problem. We had already been able to take care of all these ones, so you don't want to count them twice. Either don't count them previously or don't count them here. Do it in any way. So let's ignore it. Now all we have to do is iterate over all the possible values of x, whichever you get, whenever, like wherever you got three unchosen vertices in a row, 5 unchosen vertices in a row, 7 unchosen vertices in a row, and see if your y is greater than equal to x by 2 or not. If it is greater than or equal to x by 2, then y minus equal to x by 2 and y plus equal to x. Sorry, answer plus equal to x. Right? It makes sense. Now, which one should I prefer first? Let us say there is a portion in the polygon which is having 3 unchosen vertices in a row, and there is a portion which is having 5 unchosen vertices in a row. Which one should I consider first? Guys, what do you think? Should I consider this one first or this one? Or will it not matter? Does it even matter? First of all, tell me, does it even matter? No, it does matter. Let us say if there were two places where you had pair of three unchosen vertices and y was equal to 2. In that case, by getting rid of it with one operation, could you, like, it could fetch you, by using one operation here on this, could fetch you 3 triangles, and one operation on this could fetch you 3 triangles. So basically you could fetch 6 triangles with the help of these 2 operations. But in this case, by using these 2 operations here, you will get only 5 triangles. So I think it makes sense that if you are having a smaller value of odd unchosen vertices, consider that one first, and at some point in the else condition, that in case if y is less than x by 2, then y will actually become equal to 0, and answer would have been incremented by y into 2, because for every operation you perform, you will get 2 triangles increment. You will just get 2 new triangles, right? So guys, does it make sense? This is what will happen when we are iterating over the odd groups. After that, when we travel over the even groups, the idea is simple. The idea is really simple. Or basically, you can just run up the exact same thing like that, like this one.
Could you explain the y into 2 part?
Y into 2 part. Okay. This is something I did get by doing some drawing. Let us say that there are so many unchosen vertices. The vertices which are chosen are here, and all the other vertices are not chosen yet. And you have y equal to only 2, which is coming up to be less than the half of this. 1, 2, 3, 4, 5, 6, 7. 7 by 2 comes up to be 3. In case if you had y equal to 3, then you would have chosen this vertex, this vertex, this vertex, and you would have got 7 new triangles. But you're not having that. So I just tried to figure out this thing on my own, that what is the maximum number of triangles I can get along with these two operations, I did realize picking up the alternating points were actually giving me this ability to create something like this. Here, since y was equal to 2, I'm having 1, 2, 3, 4. Yeah, I was having 4 new triangles. And similarly, if y was equal to 1, I was just getting 1 new triangle. So basically, I can just apply every operation on alternating ones so that I get 1 new triangle in this way and 1 triangle in this way. Then the next time I apply it here, I got 1 triangle from here plus 1 from here and 1 triangle from here. So I just realized I can always get 2 into y triangles by just picking up the alternating ones. And in case if I manage to pick up all of these, then we are actually having this new extra triangle as well. That is why, if you remember, earlier I had written this thing as x by 2, 2 into x by 2 plus 1. We are getting this one extra triangle which we were not getting in the even one. So I think that the doubt should be clear now, or is it not? So you can see that for every vertex I chose, I got two new triangles. And in case if the unchosen vertex group was having odd number of nodes and I had chosen half of them, then I was actually having one extra triangle. Well, what will be the answer in this case if y is equal to 1? Okay, so if y is the 1, let us say if these are the two good ones and y is 1, then you can just simply choose a node like this to get a triangle and second triangle. Like this is the best thing I could think of if I can choose only one vertex. If I choose this one or this one or this one, in that case I would mess up this guy. Like you know that you are already having two good vertices or chosen vertices, and you can choose one extra chosen vertex. So whatever chosen vertex you choose, you will definitely get this extra triangle, right? Like you will definitely get this extra triangle, and I'm leaving one vertex here and taking this one so that I get one more. I get two triangles. And actually we should say that instead of this one as the extra, you can call this one as the extra triangle, or like whatever you want to consider as the extra. So that's all for this problem. The approach is this much only. Now during the contest, I had first of all written a different approach. Then at the contest time, I did not tend to write a cleaner code, so my code will look very messy here. But I will try my best to explain it as good as possible. First of all, this is a part of the previous problem. Everything is exactly the same till this part. After that, what I did is, in the regular polygon I had been given, for each and every vertex, I just did tend to check, hey, what is the distance between this and this? Like how many nodes are not being chosen between these two? For that, what I did is, in the given array of chosen vertices, you were having 0, 1, 4, 5, right? So for this 0, I just checked here, what is the next element? This is 1. So there are no vertices in between which are missing. Then from 1 till 4, there are 2 vertices in between. That is 4 minus 1 minus 1. Then between 4 and 5, there are no. And then between 5 and this first guy, for checking this thing, I just called this guy as, like when I would have completed the whole cycle, this will be the eighth. This is kind of something like eighth vertex, you can say, like in whatever way you want. I think this is not a hard thing to figure out. You just want to find out how many vertex unchosen vertices are there between these two people. So it turns out to be 8, or basically n plus a0 minus a of n minus 1 minus 1. For every two people, you can just say it as a of I plus 1 minus a of I minus 1 as the number of unchosen vertices in between. And for the last guy, for a of n minus 1, the next person is a of 0. So a of 0, which is having a value of 0, which I don't really want, so I'm calling it as a of 0 plus n, and then subtracting a of I from it, and then minus 1. Basically, this is the next guy, this is the current guy, this is minus 1, which will come for sure. This is what I have been doing here. Next is gonna be equal to, if I is equal to x minus 1. Oh, sorry, this is not yeah um, yeah, it's fine. If in case I am at the last element of the array, the size of the array is not n, it is x. In that case, the next guy will be a0 plus n. Otherwise, it will be a of I plus 1. The number of unchosen vertices in between will be equal to this. In case if the unchosen number of vertices is greater than 1, like you can ignore this line. Like as I said that previously I had written some code which was incorrect. Then I made some changes, but I did not remove the unnecessary content from my code. So this is one of it. You don't really need to write this extra valley thing. Just write both of these things, that hey, in case the number of nodes in between is greater than 1 and it is odd, then just push it in an array so that I will know that these are the odd number of remaining vertices. Otherwise, bet will be like this part. And actually, one thing which you can do is just, instead of pushing up all of these people, you could have even just kept track of the sum of all the bet of this. But for now, let's leave it. Then what I did is just sorted both of these. Sorting odd is important. This extra part is something you can remove from the code. And this even part is something you don't really need to sort. Even if you don't sort, it's fine. Because like for even cases, it does not matter, since for every operation you will get only 2 into, I don't know, where did I write it? Yeah, I wrote it here. For the even case, it does not matter. Where is it? Yeah, if for the even case, it does not matter whether y is greater than equal to x by 2 or not. For every operation you perform, you will get only two new triangles. So you don't really need to sort even. This is also something you can ignore. And then I'm just running up two for loops for even and odd. For even, the loop can be made simpler, but I did tend to just copy paste the exact same thing, and no need for more optimizations here. Here, this condition is the exact same thing as I had been saying here. In case if y is less than x by 2, which is the else case, you will increment answer by 2 into y, make y equal to 0, and just break, because there is no point of going any further. And in the other case, answer will be incremented by s and y will be decremented by s by 2. Similarly for even people. And at the end, I'm just printing answer. There is a lot of unnecessary content. I will just remove this thing right after the contest. So you will get the cleaner code in the PCD, in the description. So is it clear, guys? I'm not expecting you to be completely fine about this problem. Obviously, you need to dry run things on your own. And by the way, guys, in case if it looks that you have got the approach, but you don't do dry run on your own, then attending the PCD won't be a good thing for you. Then it would be something bad actually. Yeah, like focus on getting the intuition, but implementation is something you should do on your own. Don't just leave it key you have seen the implementation. Okay, so I think that I can end the PC, like end the recording, and then we can have a discussion if you want.